Good afternoon to all of you and welcome back post-lunch. Going ahead, our next session is on product watch. The speakers for this session, the moderator is Heiko Schatzinger. He's a head of renewable energy fairs at Düsseldorf GmbH, as well as founding member of the board of directors, and vice treasurer of the German Energy Storage Association Berlin. He is also responsible for the Energy Storage Europe in Düsseldorf, the Energy Storage North America, Energy Storage China, as well as the Energy Storage in India. Next we have with us Mr. Krishna M. from Regen Power Tech. Next is Mr. Soren Brahma, co-founder and CEO of Promethean Power Systems, an energy storage startup with offices in India and USA. Soren is the principal inventor of Promethean thermal energy storage system used in refrigeration applications. And last but not the least, we have with us Mr. Philip Forestier, Executive Vice President, Global Affairs and Communities, Dassault Systems. He is aerospace engineer and one of the founder members of Dassault Systems in 1981. He has vast experience on the subject of innovation and has literally seen this topic change over a period of the last 3 decades. So without wasting any more time, I'll hand it over to Heiko to take the session ahead. A round of applause for all the speakers for this session, please.
Thank you very much for this nice introduction. Hello everybody. I know that the session after lunch is always a challenge because everybody has like a nice food and is getting a little bit sleepy. So what we're trying to accomplish in this session is giving you a bit of a broader scope, and I'm very happy that we can slightly switch the topic a little bit from product watch to innovation. I think that is a better and more suitable title for this session. And as one of the famous management gurus, Peter Drucker, formulated it, if there's one single core competence that every company in this world should have, it's the capability of constant innovation. And I'm very happy to have Mr. Forestier now giving us a keynote impulse speech on innovation. So please, your stage.
Thank you very much, Anto. Good afternoon, everyone. I'm delighted to be with you this afternoon. And I don't know if, like I was saying, that because it's after lunch, so it's always a little bit difficult to start again after lunch. I don't know if I will help for you to be in a better mood after this lunch. But anyway, I would like to thank the organizers who put me in this panel to talk about a topic which is not completely related to the topic we were discussing today, but which is all around overall innovation. So I have 15 minutes for that, and let me start by a couple of charts for show you. Look at this. The election of the Pope in 2005. Well, a crowd on St. Pierre Place in Vatican near Rome. So this was in 2005. Look at the same when Pope Francis was elected. See the difference? The difference is a lot of iPhones, a lot of connections. So this is the world where we are living. We are living in a world that is moving extremely fast, where the world is becoming digital for all usages. What about social media, cloud computing, connected objects, big data, mobility? We are in a world where the slope of development for everything, and it concerns your business, but it concerns all business, is absolutely there. And if you look at one chart concerning all the industry, all the products are becoming smart. When you do a car now, you don't start by doing the chassis, the engine, and so on. You start by engineering the connectivity. And when we see the slope of development of the connectivity in the world, this is something that has, of course, a huge impact on innovation, because there is one characteristic, which is that all those guys that are connected are consumers. So the law is made by consumers. You know, 15 or 20 years ago, when you were buying a computer, HP, IBM, stuff, they were making the law, they were proposing products. Now, it's the reverse. The consumer is really willing to get this and this, and the consumer's experience is becoming absolutely critical. To me, if we want to jump in innovation, there is something that, to me, is extremely important, which is that if you want to innovate, if you want to do breakthrough innovation, we can't do more of the same thing. Because the world of tomorrow cannot be the extension of the world of today. The company who are saying, hey, I will do 10% more than last year, I don't think they will survive. Of course, we don't do breakthrough innovation all the time. We can do a lot of significant improvements that are going in the direction of those breakthrough innovation. But let me give you an example. Education. There will be 2 billion people to be trained in the next 30 years. To achieve this, we computed, and a professor of a university in Singapore told me, in order to do that, we need to build 1 university per week. Can we build 1 university per week? No. So we need to do breakthrough innovation and transformation in the way education is done. This example of education is an example you can find in many, many other industries. As far as the company I represent, this is the world of breakthrough innovation that we did all the time. I am one of the founding members of this company more than 30 years ago. I'm an engineer in aerospace. And each time of the 4 different steps of the evolution of my company, we did breakthrough innovations. The first one was 30 years ago, just to make you understand what this kind of innovation means, we had to replace the drafting table. You know the guy in the middle in front of the screen? It was me in 1978. And if you look well, I am also in this drafting table engineering department a few years before. So it was a big jump in the way engineers were working, going from drafting table to the screen. I can tell you that it's not an easy transformation. This is why when you want to impose the breakthrough transformation, the boss, the CEO, the C-level people, they have to put in place the appropriate energetic transformation and process to make it happen. Because for a simple reason, people generally they like to stay in the comfort zone. And despite all the advantages to do 3D design in front of the screen, because it's much more easy, transforming the way people were working was a difficult journey. So all this is, this was the first example. Another example is when we wanted to simulate the entire life cycle of a product. Any product in the world now is defined, simulated, manufactured, maintained digitally in the virtual world. This is a car, but it can be anything. It can be a power plant, it can be a plane, it can be any product in the world. And of course, how were we doing before? We were doing things manually or with physical prototypes. Why is it necessary to crash a car, a real car, in front of the wall to test airbags, if we can do it digitally in front of the computer? Now when we build an airplane, the number 1 is not broken, it's flying. Before, the number 1 was going to garbage, the second testing, the third the same, and at the end of the day, there were a lot of mistakes that were not done. So this kind of breakthrough innovation was a lot linked to a better sustainability, because with the digital world, you can do right the first time. And now we are in a kind of world which is different, which is all about the age of experience. Because people do not buy any more products, and doing the best products is not enough. You can do the best products as possible with engineering people, with manufacturing people. If they don't satisfy the end user consumer, it's not good. And as far as we are concerned, maybe I think a little bit of music would have been good. You know good? So, in fact, as far as we are concerned, what do? We don't work anymore with engineering manufacturing to help designing products. We work with the whole company, because the whole company needs to provide the right experiences in order to satisfy the consumer. This is the world where we are today. And we have a purpose. The purpose of our company, represented by our CEO here, is that we want to provide the industry and the society, the people, the consumer, with 3D experience universe to imagine sustainable innovation. Sustainable innovation capable of harmonizing product, nature, and life. So we don't do any more products because the products are used by consumers are in the nature, and they have their own life. So we need to simulate all this together in a very harmonized way. This is what we want to do. Another way to look at this is there are many challenges in the world. We need to do better cities for the citizens. And I think that there are huge programs in India in order to do this. We need to do better job to have resources for the humanity and the energy for the long term. We are in big trouble right now. And do you think that if we continue like this, doing a little bit better improvement every year, it will be enough in order to sustain the world for our kids and our grandkids in 1 century from now? No way. Breakthrough innovations are necessary. With respect to health, it's the same. I think that we need to completely change and transform the way the health care is done, and I will show you a couple of examples. Manufacturing industry as well. Education, I just alluded to this point a little bit before, because in education we need to train the new kids on what the next generation world will be. We need to give them the test of science. There are not enough engineers in this world, not enough technicians, and we need to provide an education which provides employability at the right level. When I recruit an engineer from school, he is already up to date. This is not the case for the moment. So I think that our journey, very humbly, because we don't do things, but we provide the solutions for people like you to do better cities, for people like those working in energy, in global health, to do a better job for the humanity, and one day or another, triggering those breakthrough innovations that are so necessary to improve this world. Let me give you an example. What if doctors could virtually analyze their patients' health and plan therapies online with simulation, wherever they are? Let me look at this little video.
That exact heart, by taking our understanding of the physics of the heart and providing that in full 3D to that cardiologist so he can actually get true representation of what's happening. So we use our 3D technology to create immersive 3D environments.
We hope that this project sort of takes the top off the box for research. In the digital world, we don't have to worry about a specific patient. We don't have to worry about legal issues. We can take those constraints off of our research and allow whatever innovations the researchers have to be tried digitally and not worry about an incorrect outcome.
Okay, so another way to another kind of transformation we will have to do anyway for this pharmaceutical industry. All the medicines are tested very often on animals. Let's try an animal to see if the medicine is good. It's not sustainable. The regulation system in the world will not accept this. So we will have to move from an in vivo testing of medicines to in silico testing of medicines. This is something that we will have to do in the future. Another example is concerning architecture. One key importance in the way we do business if we want to do innovation is around collaboration. We don't do things alone. We must not work in silos. I think one of the key diseases of this world is that people are working in silos. They don't collaborate. To make this bird nest made of Beijing, that was designed with our solution, with a Hungarian an architect, they were a construction company, different architecture company, detail design company, fabrication company, all working together as if they were in the same team. You know, at school, nobody teach the students how to do collaborative work. So this is an issue, and this is something that we need to do in order to prepare this innovation environment for the future. Another example, I took some examples, I have only 15 minutes, so I need to go quick, with respect to the mining industry. In the mining industry, we did the acquisition of a company to simulate on the ground, to make sure that when we look for minerals, companies like Rio Tinto, BHP, and so on, they put their holes in the right place as soon as the underground is well simulated. This is also a breakthrough simulation that is important for those companies to trigger. Another example is the management of the resources, and especially the water simulation. There is flooding, there is tsunamis, there is typhoons everywhere. And of course we need to simulate this. We need to be capable to simulate water and so on. And you know, all this, you can see that as a simple visualization, but there is a lot of mathematics. There is physics, there is multi-physics behind, and there is a lot of scientific things to be done in order to make it happen. Just as a side note, there were 3 Nobel Prizes that got the Nobel Prizes because they were using modeling and simulation tools in order to achieve what they wanted to do. If I take the example of a tsunami, I think that there are multiple examples where, and this is the Fukushima example in particular, where I think it would have been very good to do some kind of 3D visualization of this plant to simulate the tsunami in order to see what do we have to do when this occurs. People were a little bit lost, didn't know exactly, they were not trained to do that. I'm going early next week in Philippines, because Philippines is a country where you have tsunamis, you have volcanoes, you have typhoons, you have earthquakes, you have everything. And I think one of the issues is to find breakthrough innovations in order to test, to try to identify the way to fight these natural disasters. Now with respect to cities, coming back a little bit to our topic today, we have what we call a 3D experience city platform, which is an holistic platform that allows to do the visualization of the city and making sure that all the people involved can collaborate and work together as if they were alone, and also share what they do with the citizens. And I will show you one little video. It will be the last one I will show, and I will leave the speaker talking. So if you can put a little bit louder.
Just this past year, the world had a turning point where more than half of humanity now lives in cities. So cities are growing, they're expanding, they're also becoming denser. We're really going to have to think about how we can design new technologies for the city in different ways.
I'm Ingeborg Walker, and I'm an associate professor at Harvard Graduate School of Design. I'm also the head of the 3D Experience City project at Digital Systems. And when I'm imagining the city of the future, I'm thinking about my daughter. She's 7 years old, and I imagine her to live in a city that engages much more with the citizens, where citizens communicate actively with each other, but also have a vision for the city, and where they live resourceful with each other. What we see is a more rapid growth of the urban areas than we have ever seen before. So that puts tremendous challenges to designers, of course, in terms of where do all these people live? What are they all eating? Where is the food coming from? How do we transport people? What is the energy resources we have for them? The 3D Experience City project will be a holistic urban model, and what I mean by this is that we're looking at all the systems that constitute the city and their totality, most importantly in their relationships to one another. Infrastructure systems such as energy, water, traffic, maybe more importantly even healthcare, education, communication, and any other system you can think of that affects human life.
I'm Philippe Walker. I'm the CEO of CATIA. CATIA's focus is to design and engineer every object in the world and making virtual worlds. So the model is not a computer graphics model. It's not just that. Of course, it's the 3D representation, but it bears inside, all the material properties. It's a model with all the behaviors, all the physics. So as a citizen, you can virtually walk inside the building and understand what the temperature will be. You can make a lot of what-if scenarios.
In addition to that, also we look very carefully at the repercussions the urban systems have on the resources worldwide. And this is, of course, a pretty large project. We will work many years on that property, but if we want to have a resourceful lifestyle within the urban settlements, we of course need to understand what the repercussions are for the entire planet.
Okay, communication with citizens, this is what is important. Last chart. Of course, with all those key transformations, education is critical. It will be my last word, but if we make a breakthrough innovation that eliminates some jobs, like manufacturing jobs by hand, we need to make sure that we transform those jobs in added value jobs. Because if not, we will ask ourselves the questions, when everything will be automated, where will be our workers? What will they do? So this is a question that is extremely critical, and it is just near all the concerns we have about innovation. Thank you very much.
Yeah. Thank you very much. This was really a great talk, and after all the examples what you're doing with this software, I thought myself, oh, this would be great to simulate a smart city. So actually, this was then the end, and I'm really glad that you're here in India, because from all of the activities we're hearing that they're going to build a lot of cities also in China, and if you're tapping into that world of energy storage and smart communities, I think that would be a great benefit for the whole ecosystem.
Dr. Shandan touched a little bit on this topic this morning around the same company.
Okay.
Thank you.
Great. I think you have a booth here also in the expo, and the sad thing about this session is that we have so limited time. Otherwise, I would have opened it now for a Q&A, but he will be available for questions on the expo floor where they have a booth. Happy to engage. And one small comment from my side. I have talked to a system integrator. They do a lithium-ion battery solution in Germany, targeting the private house market. And this guy, the CEO, said, no, I got it. We completely changed our strategy. Before we were selling battery to households. Now what they're doing is they're giving a tablet, an Apple tablet, to them where they can monitor the energy flow. It's like an intelligent software system like we have just seen, and people are buying it. So they completely flipped the whole value proposition around. They were selling a tablet with the software and having the battery solution there. So it's very interesting that we should all think about these solutions to also provide a completely new customer experience. Okay, for the sake of time, we have 3 more interesting talks. Just to give you a little bit of sense for this session, it's about innovation. So I'm very happy that we have 3 very innovative companies here sitting next to me. The next following talk, we're going to have Krishna from Region. And they have a system where they integrate their wind power and solar power. And they want to do a hybrid system with storage. So they're actually looking for the right suitable storage technology. And he's going to tell you about it. In a second, I just wanted to introduce the other panelists so that the audience is knowing what to expect out of that session in the next minutes. So we start off with that. And then we move to Mr. Soren Grama. He's actually from the US, from the MIT, and they developed a solution on thermal storage. It's a cooling device for actually cooling milk. It's a highly interesting project that also links back to a lot of activities we have at our trade show in saving food, having the food chill chain stable. So that's a very interesting approach for having actually energy storage and the whole food chain, because you know there's a lot of waste from the food in the world. So it's actually, in 2 senses, very innovative and making the world a better place. And then we're moving to electronic vehicles. So we have Mr. Pandit, and he's going to introduce a solution where they refurbish cars. It's new to the Indian market because the regulation has only been there for 2 months. However, they could already install the 60 cars. So what they do is they take a fossil fuel car and they adapted to the electronic vehicles, also getting lots of attention from other governments, because actually it's giving the police cars more speed. So also very interesting new way of thinking about, it doesn't always have to be the Tesla, it can be another solution. So I'm glad to have you here on our panel. So now you have a little idea of what we're going to accomplish. A hybrid solution, renewable energy, thermal storage, and then we're moving to electronic vehicles. And for the sadness, we won't have the time for any further discussion, so the panelists will be here around, so you can grab us afterwards. So please, Krishna, it's your stage. Interesting for your talk.
Good afternoon, ladies and gentlemen. I'm Krishna from Region Power Tech. I know it's post-lunch session. I hope I don't put you to sleep. Region Power, I'll just give a brief background about Region Power Tech before I jump into the presentation. My presentation is very short, so you don't have to worry about it. Region Power Tech was started in the year 2006 with an initial focus on manufacturing wind turbines and providing turnkey solution to wind IPPs. And today, Region has grown into a company where we have more than 1,500 megawatts of wind turbines installed in India and in Sri Lanka. And the Region has interest in other parts of other markets as well. And very recently, Region launched our solar inverters. It is a 2 megawatt water-cooled system. It is a very advanced technology, and the technology is from Germany, but we manufacture in India. So in wind, we are turnkey solution providers. In solar, we manufacture the inverters and we provide the inverters. So we have both the technologies right now, wind as well as solar, and our ambitious management had a vision that we would like to provide a firm power average throughout the day, just like we get from fossil fuels. So when we integrate both wind and solar together, you get an almost firm power, and that is the way hybrid started. So I'll just go to the presentation. So the hybrid, we have a definition for our hybrid. An ideal wind and solar hybrid system is one that generates electrical energy by using optimum combination of wind and solar together by maximizing the common resources between both the systems. So that is the idea behind the hybrid. So when you look at the hybrid scenario globally, there are two types of hybrids basically. Basically, there is just one type of hybrid that exists, which is called the co-located hybrid. That is when wind and solar share broader infrastructure. They are in the same place, but they share the broader infrastructure like power evacuation, the transmission line. What we are talking about is a true hybrid, where both the technologies work in tandem together, and there is a system level integration between wind and solar. That is, the energies generated by wind and solar are pulled together into a common power conditioning unit, evacuated through a common medium voltage transformer and through the common grid. So there is a greater utilization of all the available sources, social as well as economical. So just to give you a brief background about how the standalone systems are. So a wind turbine generates energy, especially a region wind turbine is a permanent magnet synchronous based generator. So it generates variable frequency and variable voltage output, which is conditioned through a power converter, and then a 620 volt AC is stepped up to 33 kV or 66 kV through a medium voltage transformer and goes to the grid. And similarly, the same thing happens with solar, just the difference is that it generates direct DC energy, which is power conditioned, which is evacuated through a medium voltage transformer and goes to a HV line. So what we have done here is, we are combining both these energies together to a common power converter or a common ECU, and it is evacuated through a common transformer, and it is evacuated to the HV line. is our system. Of course, there are a lot of arguments, such as there is a preferential tariff to solar when compared to wind. So there are some metering ideas that we have to bifurcate how much of energy is coming from wind and how much is coming from solar. So we are also working in the regulatory front with the various utilities. So how to mount these solar panels? So there is a small idea that we have here. So every region wind turbine has 100 by 100 land around it, and mostly since India is in the northern hemisphere, the northern part of the land is shadowed by our wind turbine. Of course, it is not the same. It is extremely site specific. So we are planning to use the northern quarter of our plot around the wind turbine for O&M activities, for crane movements, and rest of the place can be used for solar panel installations as efficiently as possible. So some of the important advantages of regions 2 hybrid, why are we doing this? There is an economic case here, as well as a social agenda. We can reduce the land required for solar installations, because every wind turbine comes with a small piece of land. So we are trying to squeeze in as much solar panels as possible in the land which is already available. So you can generate more energy per square meter. That is the biggest advantage. It's a social advantage. So forest lands can be saved. There is a reduced cost in evacuation. So we are also able to do brownfield. That is, our existing wind turbines can be converted into wind-solar hybrid. We use our existing evacuation facilities. For example, a 1.5 megawatt wind turbine has a 1.7 MVA transformer, which is used only 30% of the time or 40% of the time, depending upon the plant load factor. So the rest of the available resources, we want to tap it and evacuate solar through it. So you save a lot on evacuation infrastructure. There is higher efficiency of inverter, especially region inverter works at higher efficiency when it is operated closer to the rated power. So when you pull in energies together, the power conditioning unit operates at very close to the rated power, and hence the efficiency is higher, so your losses are much lesser, the inverter losses. So a standalone wind turbine and a standalone solar inverter would end up having more losses than a hybrid inverter. The greater grid stability, the next slide will explain you much in detail. So wind and solar together gives you a flatter power output. And easier operation and maintenance. All our wind turbines have O&M team. We have almost 300 plus people working across India servicing our wind turbines. The same team will service our O&M. So the customer saves a lot over a period of 20 years on O&M, operational maintenance. So this is a very important chart that I would like to present to you. Our research and development team, they collected data from a vertical site where our 1.5 megawatt wind turbine is available. We averaged the energy generated by the turbine throughout the year over 24 hours, and we also simulated the energy generated by a 750 kilowatt solar power plant in the same location. We averaged them throughout the year over a 24-hour span, and this is the graph that we get. The yellow one is the solar output. You can clearly, the y-axis is the power generated and the x-axis is the hour of the day, and you can see that the yellow graph of course is solar. It peaks during the noon and drops during around 4 o'clock in the evening, and wind especially is high during the nights, dips during the day, and again peaks during the evening again. So when you add the green and the yellow graphs together, lines together, you have a very almost flat hybrid graph. So you can see that the orange one is almost flat, which is much very closer to the energy generated by a conventional source. is where you have that dip. So this dip is what we want to compensate through storage. So we can provide a flat output, that is a green portion. If we can store whatever is above the green portion into the storage device and give it to the grid when we actually need it during 4 to 8 p.m. So key areas of saving, the business point of view, you save almost 3% in land because you're trying to use existing land. You're saving around 6% on power evacuation. You're saving 3% on yard electricals. You're saving 7% on inverters, and the total comes to around 19%. So if you are doing a standalone solar park, you will be spending almost 20% higher than when you're going for a wind solar hybrid. And of course, as I had mentioned earlier, you have a perpetual saving on operation maintenance because the OIM is common between wind and solar. So I just would like to conclude by saying that at Region we are very excited about this new product. We feel this is going to be the next thing. With wind, solar, hybrid and storage together, we are very confident that we can completely have an alternate source of energy for fossil fuels through renewables. And we would like all of you to support in this. Thank you.
So thank you very much, Krishna. Exciting. And I was about to say that for really a true hybrid, you need to have energy storage, I would say. Just solar and wind is not really the...
We are almost there, but
yeah,
you need a little bit of storage to make it flat.
Yeah. And I mean, you're here. Yeah, you're looking actually for sourcing partners. Yeah, I mean, that's the exciting thing about this. It's really happening, and large companies that are doing projects are actively looking into that, and I think that's a great sign to all the market. So, it's your stage, Mr. Grama. I'm looking forward to your talk.
Thank you. Actually, it ties in quite well with the previous presentation. We fill in that gap where energy storage has to be filled in, and I'll show you how. Actually, energy storage was not something I set out to develop when I started the company. We just stumbled upon it as a necessity, and I just want to give you the story of how that came about. A lot of people ask me, what am I doing here in India? I'm not Indian. I actually grew up in Romania. But I was working with some students at MIT when I was doing a graduate degree there, and I started looking at the Indian market it just seemed like an interesting market, there's a lot of needs, a lot of things to do here. So that's how the company got started. Actually, my company in 2007 started focusing exactly only on the Indian market, and we went through quite a journey to come up with a product which I will describe to you. Our offices are in Pune. We have a factory in Pune, so we make everything that you'll see here in India. And we have a research office in the United States, in Boston. And I go back and forth between the two. I actually live here in India right now, permanently. So the inspiration for this product was just a trip that we took in 2007 here in India. It was my first time in India. And we were, like I said, I was working with some students at MIT that had developed some solar concentrating technology. And I came here to get to do a market study to see where this would fit. And this was a classic case of a technology looking for a market. Okay, I have the technology, where can I put it? Let's try this, villages here in India would use that, and schools and clinics and all this stuff. So, we went everywhere. We spent a month here traveling everywhere, asking people how they would use this technology. Well, as you might imagine, there's not a lot of takers. This is just another one of those contraptions. I don't know what it can do, but I have lots of other problems in my hand. How can you help me with those? And this is how we stumbled upon the problem with the dairy industry here in India. It was actually a cold call that my business partner made in Bangalore. We're in just Bangalore with nothing to do on a Saturday. A cold call the managing director of Bangalore Dairy, one of India's largest dairies. And he said, we have this solar technology, would you be interested? And so we said, yeah, sure, come. We met, we walked into his office, he had 14 of these engineers with him to tell us about their problem. Not what we were trying to sell, but their problem with milk collection in India. And for those of you here Indians, you know what I'm talking about. India is the largest producer and consumer of milk in the world. right? And all this milk is collected from small individual farmers that bring in 5 or 10 liters of milk to a collection centers. As a result, it's very difficult to collect that milk. If you're a dairy, like Bangalore Dairy, and you try to collect 2 liters of milk a day, you have to go and touch all these villages and all these farmers to bring that milk. They told us, in that session, they told us the milk is very low quality because it sits around in hot conditions for 5 hours before it reaches the processing center. I have to go out twice a day to collect that milk, morning and evening for the milking, when the milking happens. It's a lot of operating costs, and I cannot go very far away because I'm limited by this 5 hours of time before the milk spoils. So, now there's the root cause of that. We try to analyze that. It's a very, very simple approach to solving all this, right? You just put a refrigeration system in the village, and you solve everything. You can keep the milk fresh, you can collect it once a day, all of that, and it's done everywhere in the world except in India. Because in India, you have a bigger problem, and that's the power supply. Right? You don't have reliable power supply. And dairy industry is a 24-hour-a-day, 365-day-a-year, milk never stops flowing kind of industry. So you need power, reliable power, to chill milk in villages. And so, with this insight, we started looking at how can we solve this. So, we have no product at this point. Everything that we were working with solar earlier, we just tossed it out, and we started focusing on this industry alone. You know, it's a big industry, it seemed like a good business opportunity, so that's how we ended up starting the business. Now, how did we, first we analyzed what's done out there. They have lots of these systems called bulk milk coolers. You see them in some villages. They put in it's a big industrial tank, you pour the milk in there, you chill it down to 40 degrees. And this is, I'm talking about the raw milk that comes from farmers. They pour it in here, 1,000, 2,000 liters. They keep it there for up to, say, 12 or 24 hours. And then they transport it to a processing center where they turn it into yogurt, liquid milk, and all that stuff that we buy at the store. But because there's no reliable power, you put a diesel generator with that. So now you double your capital cost. And you triple your operating cost because you have to run it on diesel. And that's the only solution that they had at that time. So we tried to find something better. Now, because of my experience with solar, and I'm an engineer, I'm an electrical engineer, and I was very passionate about solar power, I said, well, that makes a lot of sense, right? We can use solar. India is a hot country, a sunny country here. We can just put solar panels, and we can fill in that gap of unreliable power. We actually set out and built the first prototype in 2009. We came to with that prototype here in Goa, of all places. We spent 3 months in Goa testing this prototype. We were actually cheating in this. We were using ice delivered from a nearby ice plant, sitting there at the village. We were chilling the milk and then transporting the milk, the cold milk out. So the idea was we use the trucks that come in to collect the milk, empty, we'll fill them up with ice, and then come back with the milk. And that was sort of a business model innovation that we were attempting. And solar power was kind of filling some of the gaps there. But it didn't work. We invited a lot of dairies to come to look at it, and 9 out of 10 said, this is not going to cut it for me. I don't want to transport ice. I have enough headaches with milk trying to get this fresh milk out of villages. I don't want to have to deal with ice. So they challenged us to build a bigger system with more solar power, actually generating energy right there at the village. So in 2011, a year later, we came out with this bigger system, and we actually had a customer that purchased this. This is one of India's largest private dairies in the south. So here's a system that uses 2 kilowatts of solar power. It had a compressor that was generating refrigerator cooling power. And one of the things when I designed this is that if you think about solar power, it comes in at 6 a.m., let's say 7 a.m., and it sets at 7 p.m. But milking occurs outside that window. It occurs in the morning at 6 a.m. and in the evening at 6 p.m. You don't have solar power during that time. So the only way to use solar power is to develop some way of storing that energy. And because we're doing refrigeration, we thought of using thermal energy storage. Not electrical storage, not electrical batteries, but energy storage. And the simplest way, thermal energy storage, the simplest way to do it was with a big tank of cold water. So basically, during the day, when the sun was out, we ran a compressor which chilled this big tank of water. If you see it here in the picture, on the right-hand side is this big kind of shiny thing over here on the lower right-hand picture. And, it worked great. And 500 liters of milk were chilling, and we're storing that energy, and I was very proud of myself. The day we commissioned the system. This was at the dairy plant in somewhere in the south. We invited the managing director to come look at it, and he took a look at it and said, it's not going to work for me. It's too big, too complicated, costs twice as much, and we're only showing 500 liters of milk. And right then and there, he cut out all of our enthusiasm and everything. We spent years trying to develop this, and we're running out of money. We're a small startup, and this was very, very devastating for us. In fact, I had to lay off my engineers. We were, like I said, running out of money. I spent a couple of months rethinking this strategy, like, what are we doing with solar power? Is this working? Why it's not working? And then the thought occurred to me that if we take out the solar power out of it, and we just run it on grid electricity, and use the energy storage as a way to fill in the existing grid, we may have a solution. And in fact, that's what happened. We threw out solar, which is a very difficult decision, kept the energy storage, and plugged the system into the electric grid. They have power in these villages. They have 8, 10 hours, sometimes even 15 hours of power. We can just use that power whenever it's available, night, day, evening, morning, store that energy very quickly into this energy storage device, and then we have it ready to chill the milk. So with that, we came back a year later with a much bigger, better device. You see the energy storage. We spent more focus on it. It's in the background over there, a big tank. Since then, we actually re-engineered that and made it even smaller, and this is what the system looks like right now. The blue tank over there in the background is the energy storage device. It's a thermal battery that stores enough energy to cool 500 liters of milk, which is a lot of energy. And with this, we went to market, and I'm proud to say that we have about 80 systems out there. There are many of them out in the south, some of them here in the north, Mother Dairy, Amul. All these big Indian dairies are the customers that buy these systems, place them out in the village, and farmers use them there. And not a single system has a diesel generator with it. And that's because of the energy storage. And I think as of now, if I keep tally of it, it's about 2 megawatt hour of energy storage, thermal energy storage, that's doing a really good job here in India, replacing or filling into that unreliable power. So that gets me back to my earlier comment, in the south, whenever they have power, 7, 8 hours a day, 12 hours a day, but when it's not available, we fill in with that energy storage. And that's how we came up with it. Thank you so much.
Thank you, Soren. That was a great and inspiring talk. So I think for everybody that hears in the room, I think that all true respect that after 2011, the Gen 2 development, you did not give up. I mean, that's basically, it must have been a tough time, and you just kept on powering into the idea. And I think it's really inspirational for also the crowd we have here in the room. We have to think it's still a young industry where we need innovation, and innovation needs power, personal power, by innovators that just go the extra mile. And so thank you for that. And also, it's interesting how diverse the universe and the ecosystem of this whole industry will be in the next 10 years. I can imagine there will be a lot of solutions that just take the technological possibilities that we have now and capitalize on. So, great. Another solution that we have, which is also capitalizing on technology and regulation. I don't know if there are still regulators here in the room, so not natural. So without regulation, it's difficult in some markets. So now you have the regulation, and now you have the systems. And I'm really looking forward to your talk now. And again, our speakers will be in the audience. I forgot to mention that Krishna from Region, they have a booth in the expo where they can give you more information about the system. So please, after the session, approach us, approach the speakers. Now it's your stage.
All right, thank you. So starting with energy generation in food, I'm going to cover a little different area, which is automotive and vehicles. What we have been doing is looking at the transportation area to identify what can be done differently and what can be done to have a significant impact across different different use cases, across different geographies, across different needs. And the presentation talks about a couple of things we have done, and I'll end with a little, kind of giving you a better idea about what we do as a company. But let me kind of start off with the present day scenario in a sense. Even if you look at only India, you've got 120 million vehicles on the road. The new technology, the new emission norms come only for the new vehicles. So for example, in India, there are about 2.5 to 3 million vehicles, not the two-wheelers or the three-wheelers, but four-wheelers, trucks, etc., which are purchased. So, and in India, as all of you, as you have experienced here, nobody scraps any. So you have very old vehicles running on the road, and this is the case in most of the developing world as well. The old vehicles are higher in pollution, they have higher fuel cost, which hurts the businesses as well as the people who have to use them. And this has an impact at a national level in shape of the fuel consumption and especially import in countries like ours. And it also has an impact on the individual. The smog which you see here and in almost every other big city, the fuel cost which is a part of the budget, and it hurts every time the fuel goes up. Last month or so has been good because the cost prices have been going down, but overall trend is fairly clear and it's on the way up. So we believe there's something which needs to be done for the vehicles which are already on the road. You can't have them, you can't force them to be scrapped. At the same time, you can't continue flows of vehicles to run at that kind of emission levels. So what we did was we created a system which can be installed in existing vehicles and make these vehicles hybrids. So these are fuel and electric hybrids. The system actually brings down the emission by anywhere around 30%, it's plus minus depending on different vehicles. The emission goes down by 30%, the fuel consumption goes down by 35%, and that makes an impact, and that's really the carrot, in a sense. Why should somebody buy this? And the design is such that the payback has to be very reasonable. Krishna mentioned 20 years of operation, etc. Automotive, we are not that lucky. The vehicle has to pay back very quickly. In markets like India, it's 2 to 3 years. So the system is designed to have that kind of a very short, aggressive payback. The solution has different components such as a battery and a motor and a lot of other kind of connectors, etc. The motor is actually connected to the engine, and we have our own sensors, and we have an electronic control unit, the ECU, which monitors the vehicle as well as the driver expectation and ensures that the net energy which is provided between the motor and the engine is optimum for the driver, and the selection of the source is based on what is best. Because there are situations where the engine is doing very good and it doesn't make any sense to have the battery used up, and there are situations on the other side as well. So let me just quickly look at a couple of points. This is something which can be installed in 4 to 6 hours. So you don't have to give the vehicle for a month or for a week and say, no, I'll come back. It's half a day. You leave it in the morning, by lunch, you're done. The vehicle actually, because it has the electric motor, means the amount of gear change in a manual vehicle, which is again very common in developing world, goes down. So you can leave the vehicle in second or third gear, and that kind of takes care of you all the time. In a sense, it's like an automatic transmission. Our system, because it doesn't do any changes to the engine, means you can do it on a diesel vehicle, you can do it on a gasoline vehicle, you can even do it on a CNG vehicle. Now CNG vehicle, the weight issue becomes something which is one has to be sensitive about, because you have a battery which is heavy, you have a tank which is heavy, but otherwise that's also possible. Naturally, when you have an electronic control unit, telematics is very easy, and that helps a lot of information to come out of the vehicle so that remotely you can do a lot of value-add services and enhance the experience. I got a few pictures down there of the vehicles. The first one is a Tata Magic, the next one is a Suzuki Alto. We have been doing this technology both from an aftermarket or a retrofit point of view, as well as from a vehicle manufacturer or OEM point of view. And there are programs which we are doing with vehicle manufacturers, and there are programs we are doing it for the aftermarket. What was talked about earlier was, this was very interesting. We have been going around the world and talking about this, and when we went to Malaysia, they have a green blueprint, as they call it, and the police needed to work on giving their emission reduction contribution. And they said, actually, your system will be good because we'll be compliant, but actually it will help me during my pursuit mode because that motor is going to make my vehicle more powerful. So there are different people who have different needs, and this is kind of working in a couple of places. We've been working on this about 5 odd years, and what we realize is what we have is one particular application, one particular technology, and that doesn't fit all. So we started looking at more of a roadmap, saying how can we answer all the different segments and use cases in a sense. The big blue box on the top talks about public transportation, and part of the smart city as well as livable cities is encouraging people to take on public transportation. And public transportation, especially in India and a few other places as well, has a lot of problems. And one of the biggest problem there is that the fuel cost is very high, and most of these operators are bankrupt, if not, except only on paper. So we've designed something which makes sense there, and we're also working on future technologies, be it fuel cell or even potentially a pure electric vehicle. And this will, the fundamental basis of all of this technology is to design something which will be affordable. A technology which will have mass appeal both from the benefit point of view, but also from the cost point of view, something which is the basic premises of what we are doing. The next slide talks about the bus system as such. The diagram there talks about how the motor is integrated into the bus. This is a front engine, rear wheel drive, which is what you see in India. Most of the places outside, you have engines which are also rear, so the technology is slightly different. But fundamentally, it does the same job. What we have done here is that instead of having one large motor or a couple of motors, we have designed a motor pack, which you can configure it based on what the driver or the city requirements are. And you can have it optimized for that specific requirement instead of carrying what can be over-engineered or over-spec solution for the particular market. You would obviously have fuel emission reductions as well as fuel cost reduction. The interesting thing here as well is to improve the driving conditions of the driver, because that's one place which tends to be ignored in most of these markets is the driver who has to drive this bus, he has a miserable life. The vehicle is very difficult to drive. There is no suspension whatsoever, and he has to be very careful because the roads are chaotic. So if you can reduce that stress on managing the vehicle by using the electric system, that helps a lot as well. And what we have done here is basically it's a scalable architecture. The number of motors can be increased or reduced, and that will decide how much of benefit, be it a small hybrid or a mild hybrid, or a full hybrid, a range extender, or even an electric vehicle. So that's the couple of points we wanted to share about. Just to give you a quick background about us as a company, KPIT is about $450 million company. We are based out of Pune, and we work with a lot of vehicle manufacturers. That's where our experience has come from over the years, and located in different countries, 16 different countries, 34 offices. So that's what I had. Thank you.
Yeah, thank you very much, Mr. Pandit. Awesome, indeed. I didn't know that. I mean, your company is huge, and you do very interesting short payback time, 2 to 3 years. I mean, I'm attending a lot of storage conferences, and there's always this discussion about bankability, financing, cash flows, and I think it's awesome to have a payback time of 2 to 3 years, and you build the system in 4 to 6 hours. That's Formula One style. I have just one question to you, because it occurred to me, Tesla is doing this thing, they have their charging stations and they give you the power for free, and you have shown your technology roadmap. Do you have a thinking of a strategic roadmap to also go into power production or team up with a power producer, like for example region, and then you say every car that is retrofitted by us gets the power cheaper, and then you build stations? Is that a fancy idea you have, or?
So as a part of our roadmap, we are definitely looking to see how we can have truly kind of green, well-to-wheel technology. Right now we are more on the fuel tank as such to tailpipe, and having green energy available to solar or hybrid technology is something which will start making sense. The reason why we have not really started working very kind of aggressive manner in that space is that the whole grid infrastructure needs to be stabilized, and there are a lot of places, especially at state regulator level, which need to be cleared before we can do that.
Yeah.
Because when you have a plug-in hybrid, when you have power with the vehicle, it's a very kind of obvious next step that you can do arbitrage. You can sell the power into the grid when the price is right, and not a lot of states are allowing that. So hopefully, with those things coming out, getting stabilized, that can be something that will start making sense.
Yeah, I mean, that's then what next. You can do ancillary services, but I mean, you can say every car that has been retrofitted for us gets the cheap solar power, and you could build stations. And I'm sure you're working on all of that together with Rahul and his team at the India Energy Storage Alliance, which is doing a fantastic job here in India to promote the merits of storage to the regulators and to have a real breakthrough. And all of that in the room that are not yet familiar and supporting India Energy Storage Alliance to say, please give your power, human resources, people, and also financial commitment to India Energy Storage Alliance, because they help to create an ecosystem here. And then there's a multi-billion-dollar market. Yeah. So for the sake of time, I have some remarks. I would like to thank first of all my panel for the inspirational talks. I hope it was worthwhile for you after lunch, having some energy injection. And thanks also for the time discipline. Awesome. I didn't have to say any word. It was just on time. I'd like to thank the audience for your patience listening. And I'd like to quote Philippe Forestier, who had in his talk, I think he's at his booth, but he said something along the lines that, where do I have it? You have to listen to your customer, and it's not about the solution, but you have to make the customer experience better. It's not about the best practice, that's what he said. And that's also with us here, organizing Energy Storage India. We try to do the best product in a conference, in an expo for you, but without your feedback, we cannot make it better. So you have these on your, with you. So please it's just a minute for you to fill it out. Give us your feedback. We really need that. We really appreciate that, because we want to make this conference the best experience for you on the next years, and we need your input to make it better every year. So please take a minute, fill this out. Maybe now, just do it quick, because you have it all in your head. Just put it on paper and give it to the ladies and the gentlemen here. So thank you very much.
Thank you, Mr. Schulzinger, and all other speakers. As a token of appreciation, I would like to get please. And if Rahul, you can please come over and do the honors. And please do fill up the feedback forms before you leave for the day. We really need those feedback forms, so kindly fill them up before you leave for the day. A big round of applause for all our speakers in last session. Moving on, the next session for the day is commercial and industrial applications. In this, we would look into